Hi everybody. I thought a screencast describing a little more about when to release CoreFoundation objects, not only knowing when to release them, but when not to release them. But there's sort of a corollary to that, and that is if you get a CoreFoundation string that you're not supposed to release, do you have any other responsibilities? The answer is yes, you do. But first, let's talk a little bit about why are they different from everything else and what happens differently? Why are we going through all this maneuvering? So first, let's look at a standard variable that's in your program, and you probably have lots of these. An integer variable named position. The compiler builds this for you, gives it an address. You can put data in it, certainly numeric. You can take data out of it. You don't have to reallocate it. You don't have to do anything. You simply use it. And that's because the compiler's already allocated that storage for you when the program's built. Similar thing happens if you have static arrays that are dimensioned at a certain size, and the arrays are based on, say, FB records and so forth. This is all statically sized for you so that it's available to your program when it runs. Besides having static things, there are dynamic things that need to get allocated when you run. And that's what CoreFoundation does. It allocates dynamically. Some things are allocated where you're responsible for releasing it. Other things are allocated and then released where the runtime does it for you. And I'm going to get into that in just a second. So let's first of all talk about how do we recognize when the programmer is responsible for releasing the allocated memory? First way is to look for keywords in the name of the function. In this case, we're creating a mutable array. The keyword is create. If you see the word create, if you see the word copy, if you're looking at Objective-C and you see the word copy in a method, or you see the word init or allocate init or copy, that means the programmer is responsible for disposing or releasing that memory, okay? And the memory is basically the object that is pointed to by the address that's in the variable. Well, let's talk about when you have access. You have access when you provide it to yourself. And I'm not trying to be funny there, but here we are in a local function. So typically in a local function, you have access to your local variables unless pointers were passed in to give you access to variables outside. But let's ignore that for right now. So in this case, we allocate a mutable string, we put something in the mutable string, and then at the end of the function, before it exits, we release that string. Good, we're done. That's all wonderful, and that's done the way it should be. Let's just say, though, let's say we forgot to do that release. What would happen here? We'd allocate the string, our function would end, and would we be able to release that string? The answer is no. We would not. It would still be floating around in memory and consuming space. Why? Because we don't have access to this temp mute string variable anymore. It's only available within this function, at least the way the code's written here. We could return this variable to the caller or pass it back via some other mechanism like a pointer so that the caller has access to this and so that the caller could subsequently release this. But the way it's written, we would not have access. Furthermore, it creates more of a problem because subsequent iterations, subsequent times that this function's called would create more and more unreleased strings. Next time it's called, it would create another string which would not get released, and so forth. It would keep going through that cycle. So it's important to know when you have access. So you need to provide yourself access either by returning the variable and returning the object, or via some other method. Or there's also another way to do this, and that is to put your variable in, make the variable global, and then return your object in that variable. Sort of got tongue-tied for a second there. So I don't recommend global variables. You've heard me rant on this for years now, but it can make your code unmanageable. I know in certain circumstances, I've personally experienced it, it makes it virtually impossible to write certain types of code. So I would suggest you avoid that if possible. However, there's no doubting that global variables can be very helpful in certain circumstances. So that talks about what do you do and how do you recognize when you've got an allocated object, and what do you do and when are you responsible? Well, if you get it via create, copy, alloc, init, you're responsible for releasing it. Period. End of story. If you don't see those words, you are not responsible for releasing it, and you should not release it because one of two things will happen. Either the runtime will have already released it before you get a chance to release it, in which case your release is going to cause a crash, or you release it before the runtime has a chance to release it, in which case the runtime is going to create the crash because it's going to try to release a variable that's already been released. Which brings it back to the next point here, which is, well, how do I know when the runtime's handling this stuff? And that's a very good question. And in fact, if you look at, say, util string include, which just recently, thanks to some efforts by Bernie, has been it's increased in size and has a lot more calls. You'll notice all these calls in here: string with capacity, string with format. I could go on. There's a whole bunch: mid string, right string, etc. All these. You notice all of those calls do not have copy or create in them. So what does that mean? I'm not hearing you guys. Okay, what it means is you don't have a created or copied object, which means what? And you're all saying, well, it means that I don't have to release it. Yes, it does mean that. But it actually means more than that. It means that if you don't do something, that object's going to disappear automatically. So if you need to keep that object around longer than, say, the next line of code, or actually the block of code that you're in, and a block can be a long if, can be a while, can be a for loop, can be a function depending on where the variable that's holding that string or whatever the object is, wherever it's located. The basic rule is that it'll always be released next time the event loop is executed, because that's the next time that the auto release pool is consulted. Whenever you get a string or something back from a function that's not created or copied, it means that the runtime's automatically going to put it in the auto release pool for you and automatically release it sometime later. So what that means is, if you want to keep it around a long time, let's look at this substring, for example. It calls midstring. If I'm just going to call nslog and just print the contents of it, excuse me, then I don't really need to worry about how long it's going to stick around. It's going to be around long enough for me to do the nslog, without a doubt. However, if you're not sure how long it's going to be around, or if you know that you're going to need this 3 functions down the road, and so you need to make a way to keep this thing around. And the way you do that is you can either make a copy of the variable, which I'm not showing you here, but there are CF calls that allow you, and everything you see with CF means CoreFoundation, means it's a CoreFoundation call. Or if you see NS, like Nancy Sam, that is a COCO call, usually the foundation, some of the foundation calls. So you can retain this string. So you could do that, and then you could pass some var to your next function, or do something with it, but you can use it later without worrying that the string is going to be automatically released for you. So at the end of that, though, you are then responsible for doing a what, everybody? Right. You're then responsible for, after you write all that code and call all those functions, you're then responsible for doing a CF release of some var. So don't forget it. Once you can do the retain, you can keep it around, but then you need to do the release as well. So that's more or less everything that I wanted to present in here. Let me just summarize by giving you the highlights, and that is, one, there's automatic variables that the compiler handles for you, and they pre-allocate a fixed amount of storage. When you're dealing with CoreFoundation and COCO calls, you're dealing a lot with dynamically allocated storage, which it will tell you that it's dynamically allocated with the create, the copy, the init, allocate. Here's an example of mutable copy. If you see those, you're responsible for releasing them. But on the other hand, you can use them as long as you need to. They won't go away automatically. Conversely, when you're using a lot of the new utilities, such as some of these new includes that have been written lately, a lot of those calls, and this is intentional, they pass you back a string that you must retain. You must decide if you need to retain it and then use it, but then you must release it if you do the retain. And again, here you could do a copy instead of a retain. Okay. But the important thing here to know is that if you do nothing, if you don't do this retain, the contents of substring at some point will disappear. And if you're not sure about what that point is, you should do a couple things. One, maybe you should retain it and then use it and then release it, or get on the list and post your specific question with your specific code example so that the list can respond and give you some better feedback about whether you need to do a retain in that case. So hopefully that was helpful, understanding when to recognize them, when to understand when you're responsible for retaining them, and why dynamic allocation is different from what the compiler does for you automatically. I hope that was helpful, and I hope you're all having a great day. Bye for now.